This next concept I want to talk about is what we call continuously compounded interest. And here's how this works. You've seen in the last video, if you watched the compounding interest video, the periodic rate I, as that increases, it gets smaller and smaller and smaller. Well, that periodic rate I was equal to the rate divided by the number of compounds. So, in theory, what happens if we could, for instance, look at this first one. If I wanted to compound daily, the formula I'm going to use is this. A is equal to P times 1 plus R over N raised to the NT. And here I know my P is, for this particular problem, it says, what is the amount on an account where $5,000 was invested for 2 years at 8% interest? So I know I'm going to invest, that P is 5,000 times 1 plus, and I see my rate, R, is 0.08. Now, I want to do this daily. So again, in a year, there are 360 days for our years. We're going to use the banker's year here. So we're going to divide this by 360 days. And then we're going to raise this to the n, which is 360 days, times the number of years we're doing it for, which is just 2. So again, remember, we're talking about a banker year, so I'm using daily as 360. So all we do in our calculators, we do 0.08 divided by 360 first. And notice that is a very small number. I'm going to add 1 to it. Leave that number as you get in your calculator. And then raise that to the 360 times 2 is 720. And I get 1.1734900012. Leave that number in your calculator. Multiplied by 5,000. And if I compound daily, my ending balance A is $5,867.45. So what this means is that every day for 2 years straight, I would compound whatever the money that I got on one day. The next, I would compound that money using this formula again to get this ending balance. What happened instead of if we did it daily? We did it instantly. And that's what the word continuously means. Daily means you're doing it by day. Instantly means you're doing it every second. So you would think that your money would grow exponentially, and it does. But there's a limiting point to where this money will grow. And we're going to be introduced to a new formula here. The word continuously means you're doing it instantly. And instantly means you're growing your money exponentially. And the exponentially thing we're going to use here, what we call the letter E. The letter E, which is the exponential. And so we use a new formula. And the new formula we have is referred to as the continuous compounding formula. And so continuously compounded the continuous formula is A is equal to P E R T, where E is the exponential approximately 2.718, whatever. You have a button in your calculator you're going to use for this, though, the E button. And it's normally attached to the natural log button or your ln button on your calculator. So, for our problem, we know that we're looking for A again. So A is equal to P, or P is 5,000 still. This time we're going to use the exponential E. And E is a constant. It's a constant. And it's on your calculator. So it's E, and E is always raised to a power. We're going to raise it to the RT. Well, our RT, our R is 0.08, and our T is just 2. So instead of doing it daily, we're doing it instantly now. And if we do it instantly, we'd expect it to be a lot more money than what we have here. But let's see how much more it is. So when we do this on our calculator, the first thing I'm going to do, I'm going to take this right here, 0.08 times 2, And I'm going to take E and I'm going to raise it to that. So 0 0.08 times 2 is 0.16. So this is just 0.16. I'm going to do E to the 0.16. And on my calculator, to get to that, I press the second key, and I have a button that says ln, which stands for the natural log. The second ln brings up the E. And E is already raised to a power, and it's going to do 0.16. And I get the number 1.1735108, which is a little bit bigger than what we did with the daily when we had the daily periodic rate. It's a little bit bigger. The daily periodic rate was 1.17349. This one is 1.17351. So it's not a whole lot bigger, but a little bit bigger. And I'm going to do this. A is equal to now. I'm going to take that number and I multiply it by the principal 5,000. And when I do that, I get $5,867.55. If you notice, over here, I got $5,867.45. So literally, I've gained 10 more cents by doing this instantly. And you would expect it to be a lot bigger, but it's not, because E is actually a limiting factor. And your money can only grow so much before it starts to limit itself off. But this is what we call continuous interest, or continuous compounded interest. So when you see the word continuously, you're going to use the continuous formula, or I like to call it the Pert formula. And it's A is equal to PE to the RT.